Good morning, everybody. My name is James Van Leeuwen. I live here in Pincher Creek, Alberta. We're going to be talking this morning about some events happening in the sky coming up shortly, December 21st. Quick introduction of myself. I have an educational background in astrophysics. I was at the University of Calgary for about 10 years, studying cosmology, everything to do with the sky, the universe, and so on. And I still work in an interpretive capacity from time to time, an interpreter and guide for the night sky at the request of national parks programs or provincial parks programs or anybody who's interested. I try to keep up to speed with what's happening in astronomy and astrophysics. There's an awful lot going on these days. It's a real golden age for astronomy and astrophysics right now. I also want to introduce Abel's assistant this morning, Stacey McRae, is behind the camera, and she's got some questions that have been collected from everywhere and anywhere, and we'll be getting into those near the end. Stacey and I both work with the Allied Arts Council in Pincher Creek. Stacey's the executive director. I volunteer on the board, and the Allied Arts Council in Pincher Creek runs this beautiful building that we're in here in Pincher Creek. I'm going to say uptown Pincher Creek. We're not quite downtown. We're up on the hill. It's a designated historic site, and we're in what is normally used as the gallery, and we're on the really windy side of the building. If anybody knows anything about Pincher Creek, it's windy here. So we got windows rattling. That's the noise that you're going to hear in the background here. So anyways, sorry about that. The Allied Arts Council runs programs here in the Lebel Mansion for ceramic arts. There's children's programming, a variety of different contexts in which we're providing engagement in the arts. And we also have a gift shop. That's right across the hall. It's here in the Lebel Mansion. So we're here this morning to talk about a big event that's coming up on December 21st this year, and it's actually two events very, very close together. The first event is going to happen at about 3:02 a.m. on the morning of Monday, December 21st, and that is Winter Solstice. Winter Solstice happens every year. It's a point in the Earth's orbit as it's going around the sun when the rotation axis of the Earth, which is at an angle to the orbit, is pointed as far away from the sun as it can be in the northern hemisphere. Okay? In the southern hemisphere, it's pointed more towards the sun, and so that's summer solstice. In the southern hemisphere, for us, it's the winter solstice. And the other event is going to happen a few hours later on the morning of Monday, the 21st, at around 6:22 a.m. And that is the great conjunction of Saturn and Jupiter. And that is a pretty rare event. It happens only every 20 years or so. And this one happens to be pretty special, and I'll explain why. I'm going to get a little ways down the road on that first. What we most want you to know, though, is where you can see this conjunction event. And I should have explained that you can't actually see the solstice. Okay? It's not something that's out there in the sky. It's a point in time, really, as the Earth is moving around in its orbit around the sun. But this conjunction event is something that you can look at in the sky. So just about anywhere here in Western Canada, and pretty well anywhere in the world, in the northern hemisphere, you're going to see it low in the southwest, okay? Close to the horizon. And I'm going to use Pincher Creek as a reference point here. Let's say you live here in Pincher Creek or you're in the district. You want to head to some location where you've got a really clear view of the southwest horizon, and that's towards the mountains. Okay? And it'll be not too long after sunset, which is around 4:30 a.m. Okay? Or p.m. And you'll want to be out there kind of no later than 5:30 p.m. Okay? To make sure that you get the best view possible. So you need for it to be dark, so the sun has to be below the horizon. And then it takes a while for the twilight to darken far enough that you can begin to see the planets Jupiter and Saturn. And they're pretty conspicuous. They're easy to find. and especially if you have a pair of binoculars, okay? And I would recommend any very decent pair of binoculars as the instruments you want to use for looking at this event. You can use a telescope if you have one. I happen to bring mine along just for demonstration here. I'll talk about that a little later as well. But get to a location where you have a nice clear view of the southwest horizon, and hopefully it's clear, fingers crossed. We sometimes, especially when it's windy like this, we get clouds forming in the lee of the mountains. Shouldn't be a problem. You should be able to see this stuff above the clouds if it's just the stuff that clings to the mountains. And you're looking for what might appear to begin with as kind of like a single point of light in the sky. They're not super bright, but they're the brightest objects in the sky in the southwest, fairly low to the horizon. And through the binoculars, you readily see that it's actually 2 points of light, fairly close together. You should actually be able to see that with your naked eye as well. That, yeah, okay, well, I can tell they're not actually just one single point of light. It's 2 points of light close together. And those 2 points of light are the planets Jupiter and Saturn. So what's going on? Why are they so close together? And it has to do with where all 3 planets, the Earth, Jupiter, and Saturn, are in their orbits at this particular point in time. And they happen to line up. Jupiter and Saturn from Earth happen to be almost right on the exactly same line of sight. Okay? And it's something that happens every 20 and a half years or so. And so it's fairly rare. You're not going to see this again for another 20 and a half years. But this year's event happens to be really special because the planets are so close together. They're going to be 1/10 of a degree apart when they're at the moment of closest approach. And how big is that? Well, the moon in the sky is about 1/2 degree. That's the angle that it subtends in the sky, typically, from here on Earth. And the 1/10 of a degree, or 6 arc minutes, is what an astronomer might say. That's going to be, what is that? You got 35th, it's 1/5 of the diameter of the moon. 1/5 of the diameter of the moon. That's not very much. That's pretty darn close together in the sky. So you'd easily be able to see them in a single field of view with binoculars, and with a telescope that's got a fairly wide field of view, you'll also be able to see both Jupiter and Saturn in the same field of view. Now, I mentioned that you can easily see the conjunction with the naked eye, if you know where to look in the sky. And again, I'm going to emphasize you want to be out there no later than 5:30 p.m. Okay? And that's when the sky is dark enough, you can see the things clearly, and you're going to have about 1 hour of time to watch it before it gets too close to the horizon and you won't be able to see it well anymore. And if it's cloudy towards the mountain, you might have even less time than that. So no later than 5:30 p.m. And I suggested using a pair of binoculars, and use good binoculars. Try and find the best pair of binoculars you can. If you've got a pair of binoculars that can magnify fairly well, these are 8x56. What that means is that the magnification power is a factor of 8. So something that appears to be 1/10 of a degree apart in the sky, through these binoculars, they will appear to be 8/10 of a degree apart. That's the angular magnification of these binoculars. It spreads things out by a factor of 8. And so you get to see a lot more detail in the sky. What's the 56, by the way? 56 is the diameter of the lenses on this pair of binoculars. So you might have a pair of 10x40 hunting binoculars or something like that. Those will work as long as they're good quality and they align the images really, really well together in your eye. Your visual cortex doesn't have to work too hard to make the images line up. What are you going to see through the binoculars? With a good pair of binoculars of magnification, I'm going to say about 5 or higher, you'll be able to see that one of those 2 dots of light actually has little lobes on it. It's not round. You'd be able to see it as someone's got ears or something. Well, that's Saturn. What you're seeing are the rings of Saturn. Those lobes are the rings of Saturn. And if you've got a good telescope with even higher magnification, you're going to be able to see very, very clearly. You'll be able to see the gap between the rings and the planet itself. Very, very cool. And of the two planets, I'd say Saturn is by far the more interesting one. That's a personal opinion. Because it's got the rings. It's beautiful. It's just a stunning thing to see through binoculars or especially through a telescope. Jupiter, it's not a boring thing to look at by any stretch, you know, everything's relative here. What you'll notice about Jupiter is that it is very bright. It's the closer planet to us, okay? So it's going to appear significantly brighter than Saturn does. And if you've got, again, strong enough magnification in your binoculars, and I'm going to say it's probably going to take more like the 8 magnification or higher, you might be able to see the bands, cloud bands, on the planet Jupiter. Okay? They're two very distinct, darker colored bands that go around the planet, you know, and there's something else about the shape of the planet for Jupiter. It's a gas giant planet. It's not like the Earth. It's not a rocky planet like the Earth. It's comprised mainly of gas, and it's spinning pretty fast on its axis. So it actually bulges at the equator, and you can see this through a telescope that the planet is wider around the equator than it is between the poles. It's not a really strong difference, but you can actually see this. But I would say the coolest thing about either planet that you can see, other than maybe the rings of Saturn, is that they both have moons around them. And Jupiter, again, okay, it's brighter. There are 4 very large moons of Jupiter, okay, that are all the size of our own moon or bigger. And they're very bright. They reflect an awful lot of sunlight that hits them. And so they're pretty easy to see. So with this pair of binoculars, with magnification 8, I can see the moons of Jupiter, 4 Galilean moons of Jupiter very easily. There are way more than 4 moons for Jupiter. It's actually got 79 known moons at this point. But the very first ones that were ever seen by a human being were the 4 Galilean moons. It was actually Galileo back in around 1608 or 1610, as I recall. And he had one of the very first telescopes, and he was looking at Jupiter, and he saw these 4 points of light in orbit around it. And so those are called the 4 Galilean moons. There's Io, Europa, Callisto, and Ganymede are the names of those 4 moons. So a good pair of binoculars, you can actually see them. And you can, night to night, see how they've moved in their orbits around Jupiter. They don't stay in the same spot. So just like our moon, moving around the Earth in its orbit, all 4 of the Galilean moons and all of the other moons of Jupiter are all in orbit around the planet. And so you watch them move from night to night. Saturn also has a lot of moons, 82 known moons at this point, and just a pile of what are called little moonlets. They're not quite big enough to deserve to be called a moon, but they found these things. They're in the rings, and there's one moon of Saturn that is particularly large and bright. It's called Titan, and you can see it with a good pair of binoculars. You have no problem seeing it with a decent telescope. So that's what you could look forward to seeing if you've got the right instruments. And the cool thing about conjunction is that you're actually going to see both Jupiter and Saturn and whatever of its bright moons are visible, all in the same field of view of your binoculars or your telescope. That's pretty rare. And the last time they were this close together, Jupiter and Saturn, during a conjunction event, was 397 years ago. Okay? So this separation of a 1/10 of a degree between the 2 planets in the sky hasn't happened for almost 400 years. That's pretty cool. So don't miss this opportunity to see something that won't happen probably again for another 400 years or longer, for all we know. So I mentioned that both Jupiter and Saturn have moons, lots and lots of them, some of which are actually bright enough to be able to see through a good pair of binoculars or a telescope. Something else about these moons. They're very, very interesting. The moons around Jupiter, some of them might have life, okay? So they're pretty sure that one of the moons of Jupiter has an ocean on it. And it is covered with ice. It's like way colder out there, that far away from the sun. And Jupiter's closer than Saturn is, so Saturn's even colder yet as you get further away. But if I recall correctly, it's Callisto or Ganymede has this ice crust, and they think there may be a liquid ocean of water underneath that crust of ice. So there are plans to go out there and actually explore that. How might we actually be able to get a spacecraft out there, landed on the planet of Europa? And I said Europa. I can't remember which of the moons it is, but they're interested to send a spacecraft out there to explore and see, like, okay, is there actually an ocean under there? And if so, is there life in that ocean? And it might be just really simple life, microbial life or something like that. But I'd certainly like to know. That would be pretty cool. Of the 4 Galilean moons, the ones that are easy to see through telescope or through the binoculars, the closest one to the planet Jupiter is called Io. And the tidal forces that it experiences, because it's so close to Jupiter, causes the planet to stretch, and it's always been kind of torqued. And that makes for a lot of really interesting stuff going on in the inside of that moon. It's got volcanoes. So that was a huge discovery. It's like, wow, there's volcanoes elsewhere in our solar system. And lo and behold, moon of Jupiter, Io, has these volcanoes. And then they discovered that one of the other moons, and I wish I could remember which one, has ice volcanoes. It's actually spewing water out. And this is again because of the tidal forces of being in orbit around this really massive planet. Jupiter is way heavier than the Earth is. I think it's close to 320 times the mass of our own Earth. Saturn isn't quite that massive, but it's a heck of a lot bigger than the Earth as well. That one moon I mentioned of Saturn that you can see both through a good pair of binoculars, but especially through a telescope. It's called Titan, and it has an atmosphere. We've known this for quite some time. It's a pretty toxic atmosphere. It's got a lot of methane. And there is a man-made spacecraft on the surface of that moon. Now, it's called Huygens. And this goes back over a decade, where we'd sent a spacecraft out to explore Saturn as a system, not just the planet itself, but its rings, all of the moons, and so on. And that spacecraft was called Cassini. And so it was orbiting in Saturn and around Saturn in the Saturnian system for years. And it had this little probe that was attached to it. And they put the spacecraft on a trajectory that took it out past Saturn, very, very close to the moon. And they dropped this probe into the atmosphere of Saturn, of Titan, I beg your pardon. And that probe is now down on the surface of Saturn. Like, this is an incredible story. It's practically miraculous to think of this, that way the heck out there in our solar system, on the surface of a moon, which you can see, okay, there's actually a human-made spacecraft out there, Huygens. And this is all to learn about, the atmosphere, what's down on the surface, and so on. So you can go on the internet and you can see the images that were recorded by this probe, as it was descending through the atmosphere. And then once it was on the surface, it managed to get a few images before it just completely froze up, because it is like wickedly cold there, like really, really, really cold. There's lakes on the surface, but they're lakes of methane. It's raining methane. It's a pretty toxic place, but you can read about it and you can see the images on the internet. Huygens is spelled Huygens, so Huygens probe. So just a quick primer on binoculars and telescopes. Pair of binoculars uses what's called a refraction of light. you got lenses, and the light is passing through these glass lenses. And the lenses are shaped in such a way as to bring the light from whatever object you're looking at to a focus. And where it comes to a focus, you can put something else called an eyepiece, and that'll take the image of whatever it is that you're looking at, and it'll spread it out further. These, like I said, these are power 8. That's fairly typical for a pair of binoculars, magnification of 8. And again, they use refraction. There are telescopes that use the exact same kind of system. Refraction telescope, it uses lenses. But the most powerful telescopes, and the ones that you're most likely to see, are reflecting telescopes like this one. And so this is an 11-inch reflecting telescope. And they work differently. They don't actually use a lens. I'm gonna just pop the top on this one. We'll take out the lens cover. The lens, I call it a lens. It's not a lens. If you look in there, you probably see a mirror. Is that showing up, Stacey?
Yeah, it is.
Okay. So that mirror in the back has a very special shape to it. Light that is coming in from a distant object hits that mirror in the back, and because of the shape of the mirror, it actually gets reflected towards a single focal point. And that single point would be way the heck out here in front of the telescope. Were it not for another mirror that happens to be on the other side of this thing you see here. So the one in the back, the big one, is called the primary mirror, and the one that's on the other side here is called secondary mirror. And the light that's coming off the primary mirror hits the secondary mirror, and it gets reflected again right back down through the middle of the primary mirror. And that makes for a really compact telescope. Otherwise, this thing, you'd need a really long telescope, right? If you want to put an eyepiece at what's called the prime focus. So instead, they make the prime focus at the back here. And this is called a Cassegrain design reflecting telescope. And this one's a little bit of a variation on that Cassegrain design. It does in fact have a lens. So you see a glass surface here, you see the reflection. Okay? It actually has a very, very subtle shape to it, this lens, which corrects the light, the direction of the light as it's coming through before it hits the primary mirror. So the mirrors are actually the most important part of the telescope, but this correcting lens helps to improve and sharpen the image that you get at the prime focus just a little bit more than they would without the correcting lens. And here in the focal plane of the telescope, at the back now, you can put whatever you want. Okay, so I've got a big fat eyepiece here that allows you, that's the eyepiece, and it fits in, this is called a diagonal, and it makes it possible to look this way instead of having to go like that. Okay, it's an awful lot more convenient. And this is where you can see whatever the telescope happens to be pointed at. So, this large of telescope is kind of costly. I do a fair bit of work with it, so it's worth it for me to have one of these. But there's so many good quality, smaller telescopes that you can buy. And for the benefit of kids, especially, having access to this telescope growing up, I cannot recommend that strongly enough. You know, to have that opportunity to go and explore what's in the sky, not just with your naked eye, but actually get some good close-up detail on stuff. Planets to begin with. The moon is a super cool thing to look at through a telescope. Even through a good pair of binoculars, looking at the moon. You can see craters. You can see the seas on the moon, as they're called, big plains of basalt. But a telescope gives you that much more power to see detail in whatever it is that you want to look at out there in the sky. And man, is there ever a lot to look at out there. So let me just crank this around again. And I can't not mention the apps that are now available for smartphones and for tablets that allow you to explore the sky. It's called augmented reality. And you got the camera on the phone, and overlaying on that is information that's augmenting what you see. with the camera, so you're pointing at some point in the sky. And on your smartphone, with this augmentation, you get a bunch of information about what you're actually looking at out there in the sky. It's a terrific way to learn about the sky, learn to navigate, learn what's out there. And so you're going around, it's like, gee, okay, well, that's a what? Planetary nebula? What's a planetary nebula? And like, wow, I sure wish I had a telescope so that I could actually get a good close-up of that interesting sounding object. Planetary nebula are pretty fascinating. Globular clusters, just all kinds of cool stuff. One of my favorite things to look at is the Andromeda Galaxy, which you can see with your naked eye if you know where to look in the sky. But it just appears as a fuzzy blob. Good dark night, you see this thing like, okay, that's not a star. It looks like a cloud, like a really tiny cloud. And nebula is the Latin word for cloud. They didn't know what they were looking at, so they just said, oh, we'll call it a cloud. With telescopes, now you can actually get some really serious detail as to what you're looking at with that nebula. And with the Andromeda Galaxy, it wasn't until, I think about 1918, that we had a telescope that was powerful enough to be able to magnify the Andromeda Galaxy to the point where we could see that it's all stars. That's a whole other galaxy outside of our own. We didn't know that until 1918, just over a century ago, that most of the nebula that we see out there, or what we call nebula, are in fact other galaxies. So with a telescope, you know, you have that much more power to go and explore the universe. Even a small telescope can make a huge difference, and especially for kids, you know, to have that opportunity to explore, to learn through experience. And they're not that expensive. You can get telescopes for not too much money. This one's a little more money, but it is a terrific, powerful tool, and I get to take it around to night sky, you know, interpretive opportunities when I'm doing sky presentations and so on. It's really nice to have this there, and when I line it up on Saturn or Jupiter, especially Saturn, and all of a sudden, boom, okay, there's the rings of Saturn. You actually get to see the rings of Saturn. That's a pretty special thing. So it's fun to be able to provide that opportunity for people to learn more about the sky and actually see these things. They've heard of them and it's like, that's real. It does have rings around it. Or it does have moons around it. Look, there's the moons of Jupiter, the 4 Galilean moons of Jupiter. So that's for telescopes and binoculars. And I'm here in Pincher Creek if anybody's interested to learn more about good optics for exploring the sky. I'd be happy to share what I know. All right, so we had invited people to submit questions for the purpose of this presentation. And we did in fact get a few questions. Stacy's gonna be the questioner, and I'm gonna do my best to answer these questions. So over to you, Stacy. What did we get?
Okay, our first question is from Mia, and she is age 7. Where do meteorites come from, and where do they land?
Okay, so this is one of my all-time favorite questions. Meteors, what is a meteor? That's the thing that you see happening in the sky. It's the event that you see happening in the sky. So this streak of light, you know, object is moving through the Earth's atmosphere, and it creates this trail of light, and it's like, wow, that's pretty cool. And especially if it's a larger object, it can make for a really, really, really bright trail. They have a name for that. It's called a bolide. And to see one of those is a pretty special thing. When you see a bolide, it's one of these things that actually lights up the ground. It's so bright it'll light up the ground. What are they? Okay, well, they're space rocks, and there's all kinds of stuff floating around there in space, and it's debris that was left over from the formation of the solar system, and that was about 4.6 billion years ago. The solar system, early in its history, was a pretty darn busy and complicated and messy place. You had planets forming out of a gas and dust, a cloud of gas and dust that had collected around the sun. It's actually the sun had coalesced out of this same cloud of gas and dust, but it left some of the gas and dust out there, and it was in orbit around the sun, and it began to coalesce into what became the planets. But initially, it was coalescing into small bodies that are smaller than planets. It's like moon-sized and smaller. And they were called planetesimals. And there were a lot of them. And once in a while, they'd smack into each other. Okay? There'd be a collision. And when that happened, especially if it wasn't like if it was a direct collision, it would disrupt both of the planetesimals, and they'd be busted up, and little pieces of those two planetesimals ended up strewn throughout the solar system. And a good chunk of it actually ended up between Mars and Jupiter in what we now call the asteroid belt. Okay? But a lot of small pieces are left over, tiny ones, smaller than the end of my pinky kind of thing. And that's typically what you're seeing when you see a meteor, this event in the sky. It's one of those little tiny pieces of space debris, no bigger than the end of my pinky finger, coming through the Earth's atmosphere. And they're moving really fast, typically 30 kilometers per second. That's hard to imagine. That's like getting from Pincher Creek to Calgary, which is 150 kilometers away, in 5 seconds. That's how fast these things are moving. And when they hit the Earth's atmosphere going that fast, they're gonna heat up. What they do is they actually create a pressure wave in front of them as they're coming through the atmosphere, and that pressure heats up the air so much that it actually starts to melt the meteor, this little piece of rock. And the piece of rock, by the way, is called a meteoroid. So the meteoroid is the thing that's floating around there out in space, and then it hits the Earth's atmosphere, and you get this phenomenon that we see from down here on the surface of the Earth, streak of light going through the sky. And usually, that little tiny piece of space rock, the meteoroid, burns up completely. And there's nothing left of it to actually, make it down to the surface of the Earth. It has to be bigger. It has to be about the size of a fist, that piece of rock. And that happens, okay? And that would be one of those bolide things that I mentioned. You get a fist-sized piece of rock. It's now come through the atmosphere, much, much brighter, much more light, and you might actually get a fragment of that survives and makes it to the surface of the Earth. And so now you have this little piece of rock on the surface of the Earth. That's called a meteorite, okay? So the meteoroid is the thing that's out there in space. The meteor is the event that happens as that rock passes through the atmosphere. And a meteorite is what's ever left down on the surface of the Earth. Now, it just so happens that I have some meteorites. I brought a few with me, and I'm going to share them here. I'm going to bring it over there towards the camera so that we can get a good close-up. So I'm going to be out of the view of the camera for the most part. This is the biggest one that I own, and it weighs about 1.5 pounds or most of a kilogram. Okay, and I'm going to give it to Stacy for a sec, and she's going to say, "Wow, it's heavy. It's heavy. It's very heavy, right?" And that's because it's made mostly of iron. It's got some nickel in it as well, so they call it a nickel iron meteorite. This one came from Argentina. It's a fragment of a much, much larger meteorite. It actually broke up into many, many, many small fragments like this one. And that was about 4,700 years ago that this object landed on the surface of the Earth. And it would have been a pretty spectacular event, I tell you. Like the light that it would have created, it would have been like daytime, as bright as the sun when this thing was passing through the atmosphere. But only for a few seconds, because it doesn't take that long when it's traveling that fast. But it broke up into these many, many small fragments, and I'm very, very lucky to have one of those fragments. I bought this in Banff at a rock shop in Banff. So if anybody's been to Banff on Main Street, there's all these cool shops that you can go into. One of them is a rock and mineral or gem shop, and they have a very nice collection of meteorites. This was one of them. Fascinating name that they have for these, Campo de Cielo, which is Spanish, Argentina being a Spanish-speaking country. It means field of heaven or field of the sky. Campo de Cielo. Campo is a field. And it's like a field, essentially, with all kinds of fragments of this. A lot of them have been picked up and harvested now. There were much bigger pieces than this one. But you can still find these all over the place. There's lots of them on the market, commercially available. I'm going to actually bring up my favorite one here. Okay, so Yeah, do it that way. Does that look pretty good, Stacy?
Yeah.
All right. This is a fragment of what is known as the White Court meteorite. And I say White Court, what do you think? Where's White Court?
Slow it down a little bit.
You
There
bet.
you go.
White Court is right here in Alberta. It's northwest of Edmonton. And like the big meteorite that I just showed you, this is a nickel iron meteorite, or fragment of a nickel iron meteorite. And this one was nowhere near as big as the Campo de Cielo meteor. And this one happened only about 1,100 years ago, estimated. Right? And this is what the fragment looks like when you find it in the ground. And there's a lot of them up there. A lot of them have been collected now. There's a preserve around this crater that they found. They didn't find the crater until 2007. And it was some hunters who were out in the White Court area. It's a little bit southwest of White Court. And they found this crater. And okay, well, there's these fragments of its metal. It didn't take long to figure out what it was. And again, there's an area where you're not allowed to go and hunt fragments. Okay? That's the crater and a little bit of area around it. It's not a very big crater. It's pretty hard to find. But outside of that, you're allowed to collect these things. So I bought this on the internet from somebody who, I don't know where they got it from. Maybe they collected it themselves. But I now have a piece of it. And this is much more special to me than the Campo de Cielo meteorite, because this is from Alberta. This is not too far away from where we live compared to this, which is down in Argentina. I have another nickel iron meteorite that I picked up when I was in Western Australia. And this is from a place in Australia called Mundrobilla. And that's an indigenous name, or Aborigine name for the place in I think it's southern Australia, where they also had a really large meteorite, and it's a field basically of these meteorite fragments. And lots of them have been picked up and like harvested, as they say. And this one obviously has a lot of corrosion on it. You can see that there's a lot of rust. I hope maybe you can see that. It's quite a bit more orange than the two before. And so I have a fragment of meteorite from another continent, in this case, Australia. And just last year, I picked up this one. If I can get it out. This is not a nickel iron meteorite. This is actually from, well, let's see, it's not from the core of a planetesimal. That's where the nickel iron meteorites come from, is from the core of one of those planetesimals that got disrupted. This one actually came from closer to the crust of the planetesimal. And it's a lot lighter. I'll give that to Stacy. And she said, yeah, okay, that's not metal. It's a lot lighter. Yeah. So, okay, where was that one found? That was in the Sahara Desert. I think in Morocco, that one came from. And like I say, there's lots of stuff out there on the market. You can find this stuff on the internet. I bought a whole pile of fragments, and this is from a meteorite in China. You remember what the name is here. There's a location, was in Guangxi province in China, and the Nantan meteorite, that's it, iron nickel meteorite. Well, this thing has like tons of fragments to it, okay? Like, lots. These are all meteorite fragments. And there are people out there who are picking these things up all the time. And you can see these ones are pretty small. This cost, it was not a lot of money at all. And the more abundant the meteorite fragments are, the less it costs to actually buy them. So for meteorites that leave very little material on the surface, very few fragments, they tend to be more expensive, those fragments. So lots of stuff out there that you can actually get, and they're cool things to have to share with people. I love putting a big fat meteorite in somebody's hands and say, okay, what's special about that, you know? And these things are 4.5 billion years old. it's the oldest thing I'm ever going to hold in my hand. That's pretty cool. And finally, for a meteorite, one of these nickel iron meteorites, if you slice it open and polish the surface, it looks like this. Now, tell me how close can I bring that, Stacy?
That's good. Yeah.
That good right there? Can you actually see the lines
On
the surface? Okay, that's the crystalline structure in the metal, the nickel iron. And in this case, I can't remember which meteorite this came from, but this is actually a slice of meteorite, okay, that I'm holding in my hands here. And the lines that you see there in the metal are called Widmanstätten lines, after some German chap, presumably a scientist, who was the first to see them, document them. And it's because of the conditions in the center of the planetesimal. A lot of pressure there, basically it had a lot of mass. And when this stuff crystallized, it had this crystalline structure. And this is what you can see in most nickel iron meteorites. Not all of them, but most of them have these lines there. So, all right, I could talk forever about this stuff. But wondering, we have more questions, right?
I think the next question was from Nora, and I think you've answered it already. It's where do meteorites go after they shoot across the Earth's sky?
Okay.
So in our last question, Mia and Nora put together themselves, and that is, what is the star of Bethlehem?
Oh, wow. Okay. The only correct answer to that question is we don't know. We do not know what appeared in the sky. And there's still a lot of ongoing research and debate about what it might have been that appeared in the sky at that time. And I just happened to be reading this morning about this conjunction event, right? That Saturn and Jupiter, when they appear that close in the sky together, well, maybe that's the event that they saw that they called the Star of Bethlehem. And so they've calculated backwards into the past, well, when would one of these really close conjunctions have happened, where Jupiter and Saturn appear as close in the sky as they're going to appear this Monday morning? And they can't quite make it line up with the time of, what they think was the birth of Christ. But there are all kinds of other events that might have been happening, celestial events that might have been happening, that might have lined up for that time. Some are saying, well, maybe it was a comet. Maybe it was Halley's Comet. Just every 76 years, Halley's Comet comes around. Well, was that one of the years? And was it a particularly close encounter with Earth, in which case it would have been really bright in the sky? Okay? See it in the daytime kind of thing. That's you can actually see comets in the day. If they're close enough to Earth, they're bright enough that you can actually see the nucleus of the comet at least. Not necessarily the tail of the comet, but we don't know what the Star of Bethlehem was. And other theories are that it might have been a supernova, which is an event that happens, there's probably every couple of years a supernova somewhere within sight of the Earth. And that's a star exploding. There's some stars, if they're big enough, in other words, if they're massive enough, about 8 times the mass of our own sun, they can finish their lives basically in this just incredible event called a supernova, where the star blows itself to pieces. And there's a little bit left. The core of the star remains behind. It becomes something called a neutron star. But the atmosphere of the star, everything else in the star, gets shot out into space and becomes part of the interstellar medium, the material between the stars. But the event itself, when it blows up like that, just an incredible amount of energy is released. Some of it is light energy, and all of a sudden, boom, there's a new star in the sky. Okay? And the last time this happened, where we had a naked eye supernova, was in 1987. And it was a Canadian astronomer working at an observatory down in South America, who stepped out at night and happened to look up at the sky and went like, that's a new star. And he knew the sky well enough to be able to say, well, okay, that star wasn't there before. So they swing the telescopes around, and he was the first astronomer to get the news out, essentially. Hey, there's a supernova happening. And that they've been watching that supernova evolve, that star. I think it's about 150,000 light years away in the Small Magellanic Cloud. You can only see it in the southern hemisphere. And it's faded now. You know, there's no, where that star appeared, it's now gone. But the supernova remnant is there, and they're studying it. They go back and they look at it over and over and over again, and they're watching as it expands, this cloud of gas and dust. Very cool. And I should clarify that the Canadian astronomer, his name was Ian Shelton, he wasn't actually the first person to notice the star. There was a technician at the observatory who was the first one to actually remark, saying, okay, that doesn't belong there. But it was who actually brought the news, you know, to the world. And Ian Shelton was the astronomer who happened to be there at this observatory and brought the news to bear. So maybe the star of Bethlehem was a supernova that was happening at that time, but we haven't been able to find a supernova remnant that would correspond, and be big enough basically to correspond to, you know, a time 2,000 years ago roughly, when we think it was the birth of Christ. It's one of several events that could have been happening in the sky at that time. So I wish I could give you a better answer. The only fair and honest answer is we don't know. Right, well, I hope you enjoyed all that. That was a lot of detail. Covered a lot of ground there. Started with a conjunction event, and we're going to finish with this conjunction event, Saturn and Jupiter appearing very, very close in the sky together, just to cover, you know, where to be, where to look for it, and what you're going to see. So if you're here in Pinch Creek District, practically anywhere else, you're going to look towards the southwest horizon no later than 5:30 p.m. Get out there about 5:30 p.m. It'll be dark enough to see these things. The sun will have set below the horizon, but you'll still have some twilight, okay? And that'll fade into darkness over the next half hour between 5:30 and 6 p.m. kind of thing. But because it's so low to the horizon, you want to be out there as soon as you can to be able to see it, because as it gets closer to the horizon, what you see through a telescope or through binoculars is going to appear more and more distorted, and it's more likely to be obscured by clouds. So try and get it when it's as high above the horizon as possible. And of course, you know, you're dealing with the Earth turning, right? That's what's causing the object to set, whether it's the moon or whether it's the planets, whatever's out there in the sky, stars and so on. When it's setting, all you're seeing is that the Earth is turning you away from that stuff and falls below the horizon. And once it goes below the horizon, of course, it's going to come up on the eastern horizon the next morning, but it'll be daylight before Jupiter and Saturn come up. You will not be able to see them because of the daylight. This is your only opportunity to see it at night. And so towards the southwest, low on the horizon, not really close to the horizon, it'll be high up. It'll be the brightest thing that you can see in the sky towards the southwest. It's not the moon. Okay, the moon is obviously the moon, and it's going to appear much higher in the sky and more towards the east. So what do you see through the telescope or through a pair of binoculars? You see 2 points of light, 2 quite bright points of light. That's Jupiter and Saturn. Saturn, with high enough magnification, a good enough quality pair of binoculars or a telescope, you'll actually see the rings of Saturn. And with low magnification, say 8 power magnification, all you'll see are little lobes on the side of the planet. With higher magnification that you get from the telescope, you'll actually see the rings separate from the planet itself. You see the gap in between the rings and the planet. That's pretty cool stuff. Jupiter, you'll see, is the brighter of the two, significantly brighter. And maybe if you've got enough magnification, you'll see the cloud bands. There's 2 very distinct dark cloud bands on the planet itself. But you should be able to see with 8 power or better, maybe even 6 power magnification, like binoculars, the 4 Galilean moons of Jupiter. And if you get to see all 4, that's lucky. Very often, one is going to be just in front of the planet, or it'll be behind the planet. It'll be eclipsed. You won't be able to see it. This is going around in its orbit. It passes in front of the planet and also behind. And to see all four of them at the same time is very cool, especially if they're on one side of the planet. You get this perfect straight line of four little tiny dots of light that are pointing away from the planet itself, Jupiter. They're much, much fainter and obviously harder to see, but again, decent pair of binoculars or a telescope, you should have no problem seeing them at all. So that's where to look, when to look, okay? The Saturn is Sunday evening of the 20th. The conjunction event itself, when they are closest together in the sky, isn't going to happen until 3:02 a.m. on the morning of the 21st. And by that time, it'll be below the horizon. You will not be able to see anything. So here in Pitcher Creek. What else was there? The solstice event. Oh, I beg your pardon. I think I messed up. The solstice, when we pass solstice, that's 3:02 a.m. in the morning. It's not something you can look at. It just happens to be a point in time when the Earth is in location in its orbit. The conjunction event is at 6:22 a.m. in the morning. That's when the two are closest together, but you won't be able to see them from here in Southwest Alberta. So the best chance you get is the evening before, and no later than 5:30 p.m. Be out there to see it, to look for it in the southwest. Fingers crossed that we have clear skies. And if anybody's wanting to ask more questions, I'm happy to answer anything anybody wants to serve up. So you can reach out to us here at the Allied Arts Council, respond on the Facebook feed that this is going to appear on our Facebook feed for Allied Arts. And with that, I'm going to thank Stacy for her help in doing all this, and wish you all a very Merry Christmas, Happy Solstice. Please get out there. If the sky is clear, you're going to see something that you won't see for hundreds of years. Is this very, very close conjunction. All right, be well, everybody.